Every single time you load a website, fire off an email, or start streaming a show, you are kicking off one of the most incredible, high-speed journeys on the planet. And today, we're going to follow a single piece of your data as it zips across the globe and back, all in the blink of an eye. So, yeah, let's follow the data.
I mean, it feels instant, doesn't it? You click, and it's just there. But what's really going on behind the scenes? That one click unleashes this unbelievably complex, elegant chain of events. We're about to pull back the curtain on that mystery, tracking the path from your screen out into the wild and all the way to its final destination.
So, where does it all begin? It begins with you. You type in a web address, you hit enter. That's it. That simple action creates something called an HTTP request. And this happens at the very top layer of the whole networking system, the application layer. You could say this is the spark that lights the fuse for the entire journey.
Okay, but you can't just toss that request out into the world by itself. No way. It has to be properly prepared for the trip. The best way to think about it is like you're mailing something fragile. You put it in a box, right? Then you add padding, you slap a label on it, and then you put that box inside an even bigger, stronger box for shipping. In the world of networking, we call this whole process encapsulation.
So, as your data moves down through these layers, each one adds its own special wrapper, its own little instruction manual. The transport layer goes first, adding a header to make sure the data finds the right application when it arrives. Then, the network layer adds another header, and this one's got the final destination. Think of it as the big global mailing address. After that, the data link layer adds one more header, but this one's different. It's just for the very next stop on the local network. And finally, the physical layer takes this whole package and turns it into electricity or light, ready to actually travel. Now here's where things get really cool. At that transport layer, a critical choice is made. Does this data need to be perfect, or does it need to be fast? If you're loading a website, you need every single piece, in the right order, no exceptions. That's when you use TCP. It's like certified mail with delivery confirmation. But what about a video call or online gaming? A few missing pixels here and there don't really matter. Speed is everything. That's where you use the express route, UDP. All right, our little data packet is all boxed up and ready to roll. But before it can hit that super fast internet highway, it's got to navigate the local streets first. This is the first leg of its journey, from your computer, through your house, to your router. To navigate these local roads, the packet needs a local address. And that is the MAC address. You can think of a MAC address like the serial number that's physically burned into your laptop's network card. It's permanent. It uniquely identifies that piece of hardware, but it tells you absolutely nothing about where it is in the world. The IP address, though, that's the global mailing address. This is the piece of information that tells the entire internet where your packet needs to end up. And unlike that permanent MAC address, your IP address can change. It's more like the address of the coffee shop you're working from today. It tells everyone where you are right now, and it's absolutely essential for any long-distance travel.
So here's the bottom line, the key takeaway. The MAC address is used to find the very next device on your local street. The IP address is for finding the final destination city, maybe halfway across the world. They work together, but they operate on completely different scales.
Okay, so our packet leaves your computer and bam, it hits a network switch. Now, a switch is a pretty clever device. It looks at that local MAC address on the packet and knows exactly which physical wire leads to the next stop, in this case, your router. It doesn't just yell the message out for everyone to hear, it creates a direct, private path. Super efficient. And just like that, our packet is at the edge of your local network. It's arrived at your router, the gateway to this massive, sprawling, global highway we call the internet. Now, the real long-haul journey is about to begin. So let's make this crystal clear. If a switch is like the internal mail sorter for a single office building, a router is like the central post office for the entire country. The router doesn't care about the specific desk. That was the switch's job. The router reads the big picture address, the IP address, the city and state, and it makes a critical decision. Which major highway should this packet take next to get it closer to its destination? And how on earth does it make that decision so fast? It uses something called a routing table. You can basically think of this as the internet's own built-in GPS. Every router has this huge, constantly updating list of paths. When your packet shows up, the router glances at the destination IP, finds the most specific route in its table, and boom, it knows exactly where to forward it. And this is the magic of the internet right here. Our little packet just hops from one router to the next, maybe crossing continents or going through undersea cables. And each one of those hops is another lightning-fast decision, another step on the most efficient path, all guided by that IP address it's carrying. After traveling thousands of miles and bouncing between dozens of routers, our packet has finally made it. It's at the destination network, at the server hosting the website you wanted. But hey, the job's not quite done. Now it's time to unpack the message. This process, which we call decapsulation, is literally the exact reverse of what happened on your computer. It's like a Matryoshka doll in reverse. Each layer carefully strips off the wrapper that its counterpart added at the beginning. The data link layer gets rid of the local address. Then the network layer removes the global IP address. The transport layer takes off its header, until finally the original, pristine data is revealed, ready for the server's application. And there it is. The server gets your original HTTP request exactly as you sent it. The message has been delivered. It's a success. And of course, now the server is going to send a response, and this entire incredible process kicks off all over again, but in the opposite direction. But wait a second, what about security? This whole trip is happening out on the public internet, and let's be honest, that can be a pretty sketchy place. Luckily, our data packet doesn't travel alone. It has some pretty serious digital bodyguards protecting it. Your first line of defense is the firewall. The best analogy is a bouncer at a club or a security checkpoint at a border. It stands there and inspects every single packet trying to get in or out, and it checks their credentials against a very strict list of rules. If a packet looks suspicious or isn't on the guest list, it is denied entry. End of story. It's simple, but it is incredibly effective. Now, for the really important stuff, you need more than just a gatekeeper. You need to make the packet's contents completely unreadable to anyone who might be snooping, and that's exactly what HTTPS does. Before a single piece of your data is sent, your browser and the server do this quick secret negotiation called a TLS handshake. They prove their identities to each other, and then they generate a secret encryption key that will only be used for this one conversation. From then on, all the data is scrambled, making it total gibberish to anyone else. And if you want the absolute ultimate in protection, well then, you use a VPN. This is like putting your data packet inside its own personal armored car for the entire trip. A VPN creates a secure, encrypted tunnel from your device all the way to a server somewhere else. So not only is your data scrambled, but your real IP address and your location are hidden. It's both secure and anonymous. So there you have it. From packing and addressing to navigating local streets and global highways, all while being protected by digital bodyguards. This entire journey, from your click to its arrival, happens in a tiny fraction of a second. And it's a journey that is repeated trillions of times, every single day, all across our planet. So the next time you click send, maybe just take a half second to appreciate the invisible, complex, and frankly beautiful technological dance that you just set in motion. Thanks for coming along for the ride.